Welcome to a webcast produced by the Learning Enhancement team, who are based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Trigonometry series and concerns the trigonometric ratios, sine, cosine and tangent. This guide introduces the trigonometric ratios, sine, cosine and tangent. Introduction. A right-angled triangle is a triangle which contains an angle equal to 90 degrees and is a very important shape in mathematics. Many problems in science which involve two- or three-dimensional objects require some use of right-angled triangles. A fundamental property of right-angled triangles is that Pythagoras' theorem holds. See study guide, Pythagoras' theorem. Just as importantly, they are used to define the trigonometric ratios sine, cosine and tangent, three of the most important concepts in mathematics. Labelling a triangle. In order to help define the trigonometric ratios, it is important that you understand how to correctly identify the sides of a triangle in relation to its angles. Let's start by drawing a right-angled triangle. This triangle contains three sides: a longest side, which is always called the hypotenuse, a side of length x, and one of length y. You also have three angles: the right angle itself, depicted by the small square, and two others, given by theta and phi. If you look carefully, you can see that the hypotenuse is the side that is opposite the right angle. In a way, the hypotenuse plays no part in the right angle, which is defined by the join between sides x and y. Okay. The hypotenuse is always opposite the right angle in a right-angled triangle. Now if you look at the angle theta, can you see that the side y is opposite this angle? So y is said to be opposite to theta. The side x, along with the hypotenuse, plays a part in defining theta and is said to be adjacent to theta. Definitions of adjacent and opposite sides are different for the angle phi. Can you see that the side x is opposite the angle phi? And that the side y is adjacent to phi? No. This is the crucial point here. When you are defining the opposite and adjacent sides of an angle, the sides you choose depend on the angle you are interested in. Moreover, the hypotenuse always remains the longest side, the one opposite the right angle. This idea of sides which are opposite and adjacent with respect to certain angles is essential in defining the trigonometric ratios. The longer of the sides, x or y, is always opposite the larger of the angles, theta or phi. Trigonometric ratios. You can use the idea of opposite and adjacent sides along with the hypotenuse to define the trigonometric ratios. The triangle at the beginning of this guide is used as the basis for the following definitions, but they can be applied to any right-angled triangle. Sine. In a right-angled triangle, the sine of an angle is defined as sine of an angle equals length of side opposite to the angle divided by length of the hypotenuse. As the hypotenuse in a triangle is always the longest side, the value for the sine of an angle is never bigger than 1. In mathematical writing, the word sine is shortened to sin, and it is never pronounced sin. The angle of interest is written after, for example, sine theta. There is no multiplication here, and the text sine theta implies the sine of the angle theta. Applied to the triangle above, sine theta equals y divided by hypotenuse, and sine phi equals x divided by hypotenuse. Cosine. In a right-angled triangle, the cosine of an angle is defined as cosine of an angle equals length of side adjacent to the angle divided by length of hypotenuse. The value of the cosine of an angle is never bigger than 1 for the same reason as the sine. When writing mathematically, the word cosine is shortened to cos, pronounced cos, and, as with the sine, the angle of interest is written after. For example, cosine theta is written cos theta. Again, there is no multiplication here, and the text cos theta implies the cosine of the angle theta. Apply it to the triangle above. Cos theta equals x divided by hypotenuse. Cos phi equals y divided by hypotenuse. Tangent. In a right-angled triangle, the tangent of an angle is defined as tangent of an angle equals length of side opposite to the angle divided by length of side adjacent to the angle. You may notice that the tangent represents the gradient of a line, usually defined as the change in y divided by the change in x. See study guide, the straight line. The word tangent is shortened to tan, or tan, with tan theta denoting the tangent of the angle theta. Again, there is no multiplication involved. Applied to the triangle above, tan theta equals y divided by x, and tan phi equals x divided by y. Interestingly, you can use the definitions sine and cosine above to show that tan theta equals sine theta divided by cosine theta, and tan phi equals sine phi divided by cosine phi. In other words, the tangent of an angle is the sine of that angle divided by its cosine. Methods to remember trigonometric ratios. Over the years, many mnemonics and memory devices have been created to help the student remember the trigonometric ratios. The most famous is probably the following word, pronounced so-ka-to-a or so-ka-to-a, which helps you remember that sine of an angle is opposite side divided by hypotenuse. Cosine of an angle is adjacent side divided by hypotenuse. Tangent of an angle is opposite side divided by adjacent side. Others include some old horses chew apples happily throughout old age. Silly old Henry caught Albert hugging two old aunts, and some of her children are having trouble over algebra. Inverse trigonometric functions. With the definitions of the trigonometric ratios, you can calculate a property of an angle, the sine, cosine or tangent, via the ratio of the relevant sides of a right-angled triangle. You can also find the size of an angle from a given trigonometric ratio value by using the inverse trigonometric functions. The inverses of sine, cosine and tangent are written as this, this and this, respectively. Here, the index does not represent a reciprocal, but an inverse. So, this is said inverse sine, not sine to the minus 1, and so on. You can find an angle, say theta from the above triangle, from the equations theta equals the inverse sine of y divided by the hypotenuse, or theta equals the inverse cosine of x divided by the hypotenuse, or theta equals the inverse tan of y divided by x. Here, the equation you choose depends on the sides that you know. These are difficult to calculate by hand, and so the use of a calculator is strongly recommended. This means you should familiarise yourself with where the inverse trigonometric function buttons are on your particular calculator. Note that the inverse trigonometric functions are also commonly called arcsine, arccos and arctan. Let's do an example of finding the value of a trigonometric ratio. Given the triangle below, find the values of sine theta, cos theta and tan theta. The 3, 4, 5 right-angled triangle is a common one. It is a Pythagorean triple. See study guide Pythagoras' theorem. With respect to the angle theta, can you see that 3 is the opposite side and 4 is the adjacent side? The hypotenuse is always the longest side, in this case 5. So, from SOHCAHTOA, and after substitution of the relevant values, sine theta equals opposite over hypotenuse. The opposite is 3, the hypotenuse is 5, so it's equal to 3 divided by 5, which is 0.6. The cosine of theta equals adjacent divided by hypotenuse. The adjacent is 4, the hypotenuse is 5, so it's 4 divided by 5, which is equal to 0.8. The tangent of theta equals the opposite over adjacent. The opposite is 3, the adjacent is 4, and 3 divided by 4 is 0.75. Notice that you do not know the size of the angle theta. Let's do a second example, finding the size of an angle. You can find the value of an angle from a known trigonometric ratio using the inverse trigonometric functions. From example 1, you know that the sine of theta equals 0.6, the cosine of theta equals 0.8, and the tangent of theta equals 0.75. You can use either inverse sine, inverse cos or inverse tan to find the angle theta. It is important that you use the correct inverse. Inverse sine for sine theta, inverse cos for cos theta, or inverse tan for tan theta. Remember that the angle does not change. Theta is still theta, regardless of the inverse you pick, so you should get the same answer. Indeed, theta equals the inverse sine of 0.6, which is 36.87 degrees. Theta equals the inverse cosine of 0.8, which is again equal to 36.87 degrees. And theta is equal to the inverse tangent of 0.75, which again is 36.87 degrees. Further guidance and information. If you have any further questions about trigonometry or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.